Hello, sixth graders. This is Mrs. Hebert, and today we are starting Module 14. So this is lesson 14.1, and we will be talking about distance on the coordinate plane. You will want to use wide boxes this time, or wide sections, and you can fit it all on one page, but you may want to spread it out to 2 pages. So the model that I'm showing puts it all on one page, but there is a lot of writing and some drawing, so feel free to use both pages, both sides in your notebook if you want to. So this is the first page. Also, don't forget to add this to your table of contents if you're writing in your notebook. In box 1, going across the top, you just want to write a couple of definitions to remember for this lesson. One is axis, which is the horizontal or vertical line that intersects at 0. And just remember that the x-axis is horizontal and the y-axis is vertical. And then the absolute value is the distance of a number from 0. Remember, absolute value is not positive or negative. It is just how far it is in either direction from 0. Okay, in box number 2, there's a lot of writing, so you may want to pause your video to give yourself a chance to write all of this down, and then you can go back and play it again to see how we solve these. So we're going to use absolute values to find the distance between 2 points. And in example 1, we're going to look for the distance between point A and point B. Point A is in the first quadrant, and it is positive 4, positive 3. And point B is in the fourth quadrant, and it is positive 4, negative 2. So because I'm looking for the distance vertically between A and B, I'm going to use the y-axis values to determine my distance. So and because they're in 2 different quadrants, I am going to add the values together. So my stylus is really big, so hopefully it's not too messy. But I'm going to look and I'm going to say, okay, I'll take the absolute value of the y value in A, which is 3. And then I'm going to add, because I have the points in different quadrants, the absolute value of y in B, which is negative 2. And so that becomes 3 plus 2, because I'm doing absolute value. And so my answer is 5 units. Since we haven't said what the units are, we just call them units. And that's the answer for example A. Now it's really easy if you look on the coordinate plane in easy examples like this. It's easy to just count the boxes if you had graph paper to count the values and figure out this is 5 units. But they won't always be that easy. And so you need to understand the process. In example 2, I would plot C, which is at negative 1, negative 4, and D, which is at negative 5, negative 4. And you can see they're both in the same quadrant. They're in quadrant 3. And they're also horizontal. I'm looking for a horizontal distance. So since I'm looking for a horizontal distance, I'm going to use the x values. And I'm going to subtract, because when you have 2 points in the same quadrant, you have to subtract to get the distance, because you're not crossing over into another quadrant. So I'm going to use the x values. So I'm going to say, and since I'm subtracting, I'll just take the bigger one. So I'll say the absolute value of negative 5, because that's the x value for D. And I'm going to subtract the absolute value of negative 1, because that's the x value for C. And that gives me 5 minus 1 equals 4 units. And that's the answer to example 2. Also, just to point out, notice I started with the absolute value of negative 5, and I said that was the bigger number. It's only the bigger value because I'm using absolute value. If I wasn't using absolute value, it wouldn't be the bigger value. But I'm looking to make my subtraction problem work. I start with the bigger absolute value. Okay, in box number 3, you're just going to write down some information and then do another example. So I said you don't need the coordinate plane if you understand which quadrants your points are in and you understand the process. So as beginners, it's easier if we use the coordinate plane. But as you move forward in math, you'll be figuring out distance. You won't always be plotting your points. So I'm just going to show you how you would do that. So to find the distance between A and B, when A is +3, +4, and B is +3, -1, I'm going to figure out a few things. So the first thing I know is that A is in quadrant 1 because both values are positive. And B is in quadrant 4 because X is positive and Y is negative. Since the 2 points are in different quadrants, I'm going to add the absolute values to find the distance. So in this case, I'm going to take the absolute value of 4, which is my Y value, and I'm going to add the absolute value of -1, because again, I'm looking at quadrant 1 and quadrant 4. I'm crossing over into different quadrants, so I'm going to add. And I'm also using the Y values because it's a vertical distance. So the absolute value of 4 is 4, and the absolute value of -1 is 1, so this becomes 4 + 1, and so my answer is 5 units. And so I didn't need to plot them. I could check it by plotting them on a coordinate plane, and I could count my units up. But if you understand the process, you don't have to do that. Going forward, when you guys get into 7th or 8th grade, depending, you will learn a formula for distance when your points don't form a straight line on your coordinate plane. But that's more complicated, so for right now, we're just going to stick with this. But there is a formula to figure out distance no matter where the points are, whether they form a straight line or not on your coordinate plane. Okay? And when I say, a straight line, I mean a straight vertical line or a straight horizontal line. When you go forward, you'll be looking at diagonal lines, and that's when the formula comes in really handy. Okay, so now you're done, and this is just an example of what yours might look like, a little bit neater, without using the stylus when you're finished. And that's it for 14.1. Good job, you guys.